Okay, so these questions are on the domain of these functions. So, if you look at if you were to look at a graph, the domain, so if you have some function, it could be a straight line or whatever, and that's what this one looks like right here. If you were to graph it, it's a straight line from left to right, and so the domain covers everything from left to right, and so that's partially why that's the answer. Basically, what you're looking for whenever you're asked to find the domain, the main thing is we can't divide by zero, so you don't want to divide by zero, and then we don't want to square root negative values. So those are really the only thing that you're going to have to look out for on these. But I'll also maybe give you a little visual on some of these, how they look, and maybe that will help also. So that first one, that one wasn't too bad. So basically there is no fraction and there is no square root, so there's really nothing excluded. Okay, now on this next one, we do have a fraction. So basically we can't divide by zero. If you were to plug in f of negative 4, what would happen is you'd get 3 divided by negative 4 plus 4. So you'd have 3 divided by 0, which is undefined. So that's why negative 4 is not included. So we don't want to include that. So using interval notation, so if you were to graph this, once again, I'll give you a little picture of this. You actually will be graphing this in our third unit. We'll actually start graphing these. So we have this thing called an asymptote that you'll learn about, and that's at x equals negative 4. And I don't know exactly what this one looks like, but it probably looks something, um, let's see, I don't know. It looks something like this and something like this. I'm not, like I said, that's not a perfect picture of it. But basically what happens is you do have a graph to the left and to the right of negative 4, but the disconnects there because you um, can't divide by 0. So anyways, actually now that I'm looking at this, to make it a little bit more accurate, actually it would look something like that. There we go, and this one would come up a little bit higher. Anyways, like I said, we'll actually spend a whole section on how to graph these, but this is known as a rational function, and so that's the notation there to exclude negative 4 from the domain. Okay, the next one, this one's probably one you're familiar with. It's the graph would look like a parabola. So if you're to graph this, it's going to look something like this, a parabola. And so it goes left and right indefinitely. And once again, I don't see a fraction, I don't see a square root, and so that's why we're going to have from negative to positive infinity. So if you were to graph this, it would go up to the left and right forever, but it also would go out um, to the left and to the right also. So, okay. Let's see our next one. Okay, this one's a little bit trickier. You won't be graphing anything like this in this course, but I mean it's a rational function. It's kind of similar to the other one we saw, except that we throw in a square root, which makes it a little bit more complicated. So there's two things here. The square root cannot be negative, but there's an extra thing there. Also, you don't want it to be 0 though either, right? So inside the radical sign, you want that to always stay positive. So you want x plus 13 to always be greater than, typically greater than or equal to 0. But the problem is the denominator cannot equal 0, right? You don't want to divide by 0. So what we do here is we'll go ahead and erase that equals to part, because if it does equal 0, that would give us a problem, because then you would divide by 0. So for example, and I think you probably had this example prior to this, if it was just f of x equals the square root of x plus 13, then you would have the equals to part on with your inequality symbol there, okay? But since it's a little different, since we do have a fraction, it's the denominator, we also want to exclude 0, so it must be greater than 0. So we'll just go ahead and subtract 13 from both sides. And so we get that x must be greater than negative 13 is what we're looking for. And that correlates with our B answer right there. So greater than. So the answer to this one right here would actually have been A right here. Because you could have negative 13. It would make it equal 0, but since it's not in the denominator of a fraction, it would be okay. So that's kind of the difference between those. Okay, I think there's one more. Here we go. Okay, so there's a couple conditions on this one, and this one's definitely a little challenging. So the first, let's look at the denominator. This cannot equal 0, so that would mean that x cannot equal 10, right? Once you solve that, that's part of it. X can't equal 10. But on the top, we'll take that expression right there, x minus 4, and that must be greater than or equal to 0. Now, it's okay if it equals 0 this time because the square root is in the numerator, not the denominator. So we'll go ahead and solve this. We'll add 4 to both sides. So we get that x has to be greater than or equal to 4. Okay, so I think the best way to interpret this might be looking at a number line. It might make things a little bit easier. So I'm going to put 0 right here. I'll put 4 right here. And I'm going to put 10 right here. Okay, so this condition is saying that our x values must be greater than or equal to 4. So that would be greater than or equal to 4 from here, and then shading this direction. But then, wait a second, x can't equal 10 though, and that's a separate condition, and that's because that would cause us to divide by 0. So I'm going to have to put an open circle right there at 10. So I'm basically going to have to hop over 10, and I keep going to 11, 12, 13, all the way to infinity. And so if you look at this, this matches up with the interval notation right here. So that's the first half from 4 to 10, and then from 10 to infinity as your second part of it right there, and we just use our union symbol right there. And so if you plug in 10, it's not going to cause any issues with the numerator. It causes a problem in the bottom part. So anyways, that one's probably about as challenging as it's going to get from what you'll see in our course. So I hope this helps. If you have further questions, feel free to email me.